Everybody, welcome to the video on lesson 8.2. And this video is going to be talking about looking at a single population. And we're going to be looking at the single population average using what's called a t-distribution. And the t-distribution is really similar to our normal distribution curve, which we see here. It's going to be used for a little bit of a different scenario, though. And it's going to be used when we aren't given some of the data we were given before. We can think back to what we did last week. We worked on problems like this, where we were given the population standard deviation. So we knew the standard deviation of the population. We knew how the group was spread. But for these problems, we're not going to know how our data is spread. And since we don't know how the spread of the data looks like, we're going to use what's called a t-distribution. The t-distribution is similar, but it's a little bit of a flatter curve because there is less known about the data since we don't know the standard deviation. All right, so generally in practice, we're not really given the population standard deviation. There's no textbook saying like, hey, the standard deviation is 8. So in the past, when the sample size was large, this was not an issue because they just used the sample standard deviation. The sample standard deviation is where you calculate the standard deviation from the given data, and then they use that. However, when the sample size gets to be really small, it turns into an issue. Like if a sample size is below 30, generally it turns into not enough data to give you a good standard deviation. So William Gosset, about 120 years ago, long story here, but basically kind of termed this t-distribution, and he wrote under the pen name student. So this is called student's t-distribution. We don't really call it students, we call it just the t-distribution. All right, so there we go. Let's talk about where this is used. Here we have our normal distribution curve, the blue curve. Then we have our t-distributions. Notice when we have two different t-distributions shown here. The red one is when n is close to 30, and the green one is when n is smaller than 30. Notice when our sample size gets to be smaller than 30, our curve tends to be much flatter. That's because we don't know enough about our data, so we can't make as many assumptions. The more data we have, the more precise we can be, and the closer it gets to be this blue curve. So our curves depend on our sample size. And n is our sample size. S is our sample standard deviation. And x is the mean. And, mu here is our mean, and x bar is our piece of data. And let's move on. So it's similar to the normal curve. It's symmetric about 0 right down the middle. And it has more in the tails than the normal curve. So it has more on the sides. And the exact shape depends on the sample size, otherwise known as our degrees of freedom. And here we go again. Then we have some routines on how to do this on our graphing calculator. We are not going to use the graphing calculator. We're going to use the calculators built into our computers or on the internet. Okay, so here we go. We have some formulas. And this is going to be very similar to what we did last week. We have x bar. So we have our average minus the error-bound mean again, and then our average plus the error-bound mean. So the whole point is to find this error-bound mean. We have this t of alpha over 2. Last time we had z of alpha over 2. So last time we did this for a normal distribution. This time we're going to calculate this with using a t distribution. S stands for the sample standard deviation, and n stands for the amount of data we have. So these are really good. This is a good slide to write down and to bookmark slide 42 here, because you will need this to do these problems. Excuse me. All right, so let's try one. Suppose you do an acupuncture study to determine how effective it is in relieving pain. You measure sensory rates for 15 subjects with the results given. Use the sample data to construct a 95% confidence interval for the average sensory rate for the population, assuming it's a normal distribution for which you took the data. So we have sensory rates, and let's see. I guess we're maybe asking people, maybe like we give them, they don't really explain how the study works, but I guess maybe we do acupuncture and then determine, we give them a scale and ask them what level they are in feeling pain. I don't really like how this question is worded, or maybe I'm not reading it correctly. So basically, we want to find what's the 95%. We want to be able to say with a 95% certainty, or we want to say, yeah, with 95% certainty, the average will fall between this number and this number. And here we have a sample set of data. All we have is this group of data. So to do these problems, we're going to go back to our calculations here. And we're first of all going to calculate the average. And to calculate your average, let me pull up my screen here. All right, so to calculate our average, you can go ahead and use this average and standard deviation calculator. So I typed in all my data with a comma between each one. And we can click on population or sample. This is a sample. So I click on calculate. They tell me there were 15 pieces of data with an average of 8.266. And down here, they tell us that the sample standard deviation is 1.6722. So it gives me all of my numbers that I need. So I can take that back here and write them down. Here's the average, 8.2267. Sample standard deviation. Take note, I clicked on the sample down here, not population, sample. It's important. And n is 15. All right, next we calculate the degrees of freedom. And so the degrees of freedom for these problems, what you do to calculate that is you take your number of pieces of data and subtract 1. So we had 15. So 15 minus 1, 14. So we have 14 degrees of freedom. And we wanted to find the 95% confidence level. And this is going to be using not an inverse T calculator, but it's going to be an inverse, or sorry, not an inverse normal calculator, but an inverse T calculator. So our degrees of freedom, minus 1 is 14. Our confidence level is 95. And there they give us the T value, 2.145. Okay. So we take that T value, 2.14, they rounded it to. So you could use your graphing calculator if you want. I used our calculator here. So that is our T value, 2.14. We know the S is the sample standard deviation, and we know the square root of n. There's 15. So we plug all that in. We calculate the EBM, the error-bound mean, 0.924. So then we take that 0.924, we add it and subtract it from the average. So there's our average. We subtract it, we add it, we get our range of values, 7.3 up to 9.15. So there we go. When we take a group of data from this acupuncture business, we have we would say we have a 95% certainty that the average of that data will fall between 7.3 and 9.15. We can then go and check our answer on a different calculator. This calculator is pretty slick, 8.2267. Sample size 15, standard deviation 1.6, and calculate it. They show some of that work there for you. And 7.3 to 9.15, 7.3 to 9.15. So there we go, that calculator. It's a great way to check our work, pretty slick. They're going to tell you what some of those things mean too. So there's our first video on the t-distribution. This is where you have to calculate the standard deviation. And there's how to do it on the graphing calculator. The next video will be looking at another example here. All right, bye.